Okay, as we verify this identity, we want to pick out which one of these two sides looks like the more difficult of the two. And in my perspective, I would say that the left-hand side looks a little bit more difficult than the right-hand side. So I'm going to begin with this side. And I know that typically I usually rewrite everything in terms of sine and cosine. However, in this case, what I'm going to do first is I notice in our denominator that we have tangent multiplied by sine minus a tangent. So we have tangent a couple different places here in the denominator. We want to end up with a tangent in our denominator. So as we get moving the right direction on this, what I'm going to do is go ahead and factor out this common factor of tangent in our denominator. So for the time being, I'm just going to write that denominator as tangent of theta multiplied by a big set of parentheses here. Factoring out a common factor, I would have to have tangent multiplied by sine to get that first term. And then I'd have to have tangent multiplied by 1 if I distribute here to get this minus tangent at the end. All right, so as we take a look there, the numerator, we want to rewrite this somehow. And just taking a look over at the right-hand side where we want to end up, we want to eventually just have tangent in the denominator. Well, right now we have tangent multiplied by something else. So if we can get rid of this big set of parentheses and cancel that out, we'll be left with just tangent in the denominator. So as we take a look at that numerator, it looks like we have two terms that are being subtracted, so a difference, and these are both perfect squares. Sine squared, I think that one's pretty obvious, but we can say this is 1 times 1 or 1 squared. So back to some of our factoring techniques, if we have a difference of squares, we should be able to factor that pretty nicely, where you split up the first term evenly. So sine and sine. And we split up the 1 evenly, so 1 and 1, but then we just make sure one of these is positive and one of these is going to be negative. So I'm just rewriting that numerator by factoring it. Very similar if you kind of go off to the side here and think, well, if I had x squared minus 1, maybe we're more familiar seeing it with an x. We would say that's x plus 1, x minus 1 as we're working on factoring it. It's really that exact same thought process or technique. It looks more difficult with sine squared, I realize that, but it really is the same factoring that we've done quite a few times in the past. So after I factored numerator and I factored the denominator, let's see, what do we have in common between numerator and denominator? Looks to me like we have a sine of theta minus 1 multiplied by the entire numerator and a sine of theta minus 1 multiplied by the entire denominator. So if we kind of pair those up, say sine of theta minus 1 over sine of theta minus 1, that creates a 1. And what we're going to be left with is what we wanted to be left with, sine of theta plus 1 over tangent of theta, which is equal to the right-hand side. So we've gone ahead without using any big identities. Mostly this was all based on factoring to reduce down, verify this identity, make sure the left-hand side is actually equal to the right-hand side. So I hope this helps out. Good luck as you're working on verifying trigonometric identities.